Hi everyone, my name is Yahan and I'm a fourth-year PhD student from University of Pennsylvania. Today I will present our paper, Bootstrapping Small and High-Performance Language Models with Unmasking Removal Training Policy. This is a collaborated work with Elior Sulem from Ben Gurion University of the Negev, Insup and Roth from University of Pennsylvania. Previous work proposed Baby Berta, a smaller Roberta-like language model, which is designed for achieving high grammaticality with small training costs. So here we show the architecture comparison of Baby Berta and the Roberta. And we can see that Baby Berta has a less number of layers and attention heads. It is also smaller in terms of hidden size, intermediate size, and the vocabulary size. The resulting Baby Berta contains like 15 times less parameter compared to the original Roberta base. Baby Berta was also pre-trained on smaller data corpus. So the first data set is the child's. So it consists of transcribed speech between children and their parents. And another one is the Wikipedia. It contains the written articles crawled from online resources. Size of the both datasets are less than 20 million tokens. The original Baby Berta work focused on the grammaticality of a small model, and it shows the comparable performance on the zero-shot grammar test suite as the Roberta. Instead, our work concentrated on the downstream tasks for the smaller models, such as the Baby Berta. The question we are interested in is, first, what is the performance for Baby Berta on downstream tasks that require fine-tuning? Second, how to improve the behavior of those models on downstream tasks? Can we use these models as starting points and continually pre-train those? So firstly, we present the performance of Baby Berta on downstream tasks. The Baby Berta has a different pre-training recipes compared to Roberta. And here we focus on the masking policy and the vocabulary. The default Roberta's masking policy is a 80-10-10 masking policy for mask language modeling training. 80% of the mask tokens are replaced by mask, 10% are replaced by the random tokens, and the rest 10% are kept as the same. Baby Berta proposed to use the unmasking removal policy, so 90% of the mask tokens are replaced by the mask, and 10% are replaced by random tokens. The Roberta's vocabulary size is 50,000, while the Baby Berta's vocabulary size is only around 8,000, and the vocabulary is learned on the child's. We evaluate the models on three downstream tasks. The first is the semantic row labeling, which recognizes the predicate argument structure in a sentence. The other two tasks are QSRL and QAMR, and they are both abstractive question answering tasks, and it's related to the semantic row labeling. Here we experiment with different combinations of the pre-training recipes, and given our results, we find out that pre-training Baby Berta with unmasking removal policy and the smaller vocabulary set achieves the best performance across different downstream tasks and for different pre-training data corpus. This is also the default pre-training recipes for Baby Berta. We also provide the performance of Roberta base on those three downstream tasks. And we can see that there is still a performance gap between the Baby Berta and the Roberta. So this leads to the second part of our work. How about continually pre-train Baby Berta on more data? So in the first part, we continually pre-train the model on 100 million more tokens, and we choose to apply unremovable masking policy at the starting point stage, or both starting point stage and the continually pre-train stage. Given the results, we find out that the unmasked mean removal policy at the starting points improves the performance on downstream tasks even after the continually pre-training stage. This again confirms the motivation of using unmasking removal training policy for Baby Berta. And at the second part, we want to see how about continually pre-training the model on more and more data. we experimented with 3 different starting points, and we found out that until like 500 million tokens, the performance continuously improves as we keep continually pre-training the model. However, we still observe that the performance is lower than that of the Roberta base. This leads to an interesting future direction, which we also want to explore. From our work, we conclude that continually pre-training leads to improvements on downstream tasks for the small model like such as Baby Berta. We also find out that employing the unmasking-removal policy and utilizing a smaller vocabulary prove advantages for those tasks. So in the future, we plan to extend this analysis to a more general downstream test suites such as glue. If you're interested about our work, please stop by our poster session, and thank you so much for listening.